Hi everyone. In this video, we'll try to demonstrate the difference between power and energy, and also demonstrate the concept of conservation of energy, that the power that I produce is equal to the power that I consume at my load. To do that, we are using now a software called Automation Studio, and that is a nice software that it can be used to demonstrate different circuits, different power systems. So we have here a very simple system. As a generator, we have a battery that supplies 100 volt. As the load, we have three resistors connected in parallel. This is how we connect our loads at our houses. So you can look to this as different loads at your houses. When we have a resistance, so they are sort of resistive loads. So it's like, for example, a toaster, a hair dryer, water heater, these type of loads that are basically heating, has a heating element, so it can be modeled as a resistance. Now, we will measure the power at the sending end at the battery by connecting a watt meter. The watt meter basically has two coils, a current coil and a voltage coil. We connect the current coil the same way we connect the ammeter in series with the circuit, and we connect the voltage coil in parallel, like how we connect the voltmeter. So that both we have two watt meters, one at the sending end to measure how much power I am producing, and one connected to the load to know how much power I am consuming, and want to see the difference between the two. Also, at the load side, we have the watt hour meter. So this will measure our energy consumption. So now let's start the simulation. I will click here. Now, because all the loads are off, there is no power consumption. So the power at the sending end is zero. The power at the load is also zero. And of course, the energy is zero. Now, I want you to watch the moment I connect the first load, okay, which is the 10 ohm, what will happen? So I will come here and close the switch. Now, you will see that there is a power now at the source side, 996.1 watt. And there is a little bit lower power, 994.8 at the load. There is a little bit of discrepancy. We'll understand why this discrepancy is there. But now watch the energy meter. Now I am counting the energy. Now the energy is basically the power times the time. So the time is the factor. So you look here to the power is constant. Power is equal to the voltage times the current. Doesn't change with the time, it's constant. But the energy here, as the time progresses, the more you use your loads, the more you have to pay, the more you have to be charged, and this is done through the watt hour meter. Now see the rate of increase to the watt hour as I add the second load. Now becomes faster, because now adding another load in parallel, so you are more current, you are adding more and more current to your system, and the power has also increased at both the source side and at the load side. Let me add a third one. That becomes very fast. And this is the situation when you connect too many appliances at your house, your energy consumption becomes much faster. But again, the power is constant. Now, when I take out one of the loads, the power reduced and the energy rate will also decrease. Now, if you remove all the loads, no power, but we have whatever has been consumed is fixed now, 41.3. This will not go to zero. That is your bill. Add another load. Now they start counting again. Now let's try to understand why we have discrepancy between the power at the sending end and the power at the receiving end. It is around 12.3 or 5 watt. Why is that? Now I will use this ammeter or this voltmeter to measure the voltage across the cable. Now this is the cable connecting the source to the load. So if I come here and try to measure this, connect the voltmeter here. So there is a voltage, it's not zero. There is a voltage drop because this software I use power cables, a cable that allow high current. So they have a small resistance, and there will be a voltage drop, and there will be power consumption here. Okay, so I am losing this difference here in the power between the source and the load. So that is interesting video demonstrate to you the concept of energy conservation. The power that I am producing is equal to the power I am consuming plus little losses in the cables, and the difference between the power and the energy, and why we are billed using the energy, not the power meter.